Okay, we're going to start Chapter 8 with a lesson on adding and subtracting polynomials. You could also just call this a lesson and entitle it Adding Like Terms, because basically all you're doing when you add polynomials or subtract polynomials is look for like terms. So we'll start with a couple of definitions. Let me back up. You may want to set up your Cornell note paper. The essential question is, how do you classify, add, and subtract polynomials? You can hit the pause button and get ready, and then I'll move on. Okay, first a couple of definitions. The first one is a monomial. And a monomial is just a number, a variable, or a combination or product of numbers and variables. It's a lot like a term. So here are a couple of examples of monomials. 18 is a monomial. Z is a monomial. Negative 4x squared is a monomial. 2.5xy to the third is a monomial. A divided by 3 is monomial. These are all just a single term, or a monomial. That's where the term comes from. Mono means one, so it's just one single term. Notice that the number 18 doesn't have any variables. It's still a term. Notice that 2.5xy to the third has a bunch of stuff in it, but it's still just one term. Now, as you look at each of these terms or monomials, each of them has a degree. And the degree of a monomial is just the sum of the exponents of its variables. So if it has a variable, it will have a degree based on what the exponent is. If it doesn't have a variable, if it's a constant that isn't 0, then the degree is just 0. So if you look at these examples, the degree of 18 is 0. The degree of this monomial z, well, the exponent on the z isn't written, but it's implied to be a 1, so the degree is 1. The degree of the next one, negative 4x squared, the exponent on the variable is 2, so the degree is 2. This next one is where it gets a little tricky. There's two variables. The first letter x has an exponent of 1, even though it's not written. The second letter y has an exponent of 3. And so the degree of the monomial is the sum of the exponents. So this one is a fourth degree, because 1 plus 3 is 4. And the last one, the only variable in there is a. It's implied to be a 1, so this is a degree of 1. Pretty simple. So you might see problems like this. Find the degree of the monomial. The example given in A is 8xy. The x has an exponent of 1. The y has an exponent of 1. So the degree of this monomial is 2. In the next one, negative 7 y to the fourth z. The y has an exponent of 4. The z is implied to have 1. So this is a fifth degree monomial. And the last one, because it's a constant, the degree is 0. Now you have to be careful. The one example that doesn't have a degree is if the constant is 0, there is no degree. If the actual number is 0, then there's no degree. But if it's an actual number like 11, it's a 0 degree monomial. Okay, let me back this up. So, if you take a monomial like 3x to the fourth, and you add to it another monomial, well, now it's no longer a one-term expression, so it's no longer a monomial. Now it has two terms, and that's called a binomial. Bi comes from the word like bicycle, two wheels. And if you add to that expression another term or subtract, now there's three different terms. Now it's no longer a monomial and it's no longer a binomial, but it's a trinomial because there's three terms in it. And if you add another term, now there's no longer one term, two terms, three terms. Now it's four terms. Well, it's not a quadnomial or a fournomial. At this point, we just call it a polynomial. polynomial, and the word poly means many. So an expression like this that has more than one term can be called a polynomial. Some polynomials we give special names like a binomial and a trinomial. Now the way this is written is called standard form, and standard form just means you're going to write out each term in order according to the exponent. X to the fourth is the highest exponent, followed by x squared, followed by x, followed by the constant. So I'm putting this expression in order of its term degree. This is a fourth degree, this is a second degree, this is a first degree, and this is a 0 degree. Okay, this is where it gets a little complicated if you don't pay attention. This is a polynomial, and this polynomial is made up of 4 monomials. The degree of the whole polynomial is just the highest degree of each of the monomials. So if I look at this one, this is a 0 degree. If I look at this one, this is a first degree. If I look at this one, this is a second degree. And remember, I'm figuring that out by looking at the exponent on the variable. And if I look at this one, this is a fourth degree. Well, if I compare all these numbers, 0, 1, 2, and 4, the highest one is 4. So this polynomial is a fourth degree polynomial because the highest one is 4. Okay, now at this point I'm going to just take a second here and compare the two, because a lot of people will get confused between finding the degree of a monomial and finding the degree of a polynomial. A monomial is always just one term. And even though this has a lot of stuff in it, x, y, z, and n, it's just one term. It's not separated by any addition or subtraction. And to find the degree of a monomial, you add up all the exponents of all the variables. 1 plus 7 plus 3 plus 4 is 15. This is a 15th degree monomial. To find the degree of a polynomial, now most of the polynomials that you're going to see are just going to have 1 or 2 variables in it. But there's going to be more than one term. So you don't find the degree of a polynomial by adding up every exponent. You look at each term separately. This first term, 3xy to the third, the degree of that term is the 1 on the x and the 3 on the y, that's 4. The second term, 4x squared y, 2 on the x, 1 on the y, that's 3. The last term, 7x squared y to the fourth, 2 on the x, 4 on the y, that's 6. Well, the biggest number up here for each of the monomials is 6. So this is a 6th degree polynomial. And that's it. So if I give you some examples and I ask you to write it in standard form, first thing you're going to do is rewrite it so that the exponents go from largest to smallest. So in example A, I'm going to rewrite this. Start with the biggest exponent, negative 12x to the third, plus the next biggest, 3x, plus 4. I've rewritten this polynomial in standard form because I've rewritten it so that the exponents go from big to small. The next step is to figure out what the degree of this polynomial is, and then I just look at each term. This is an x to the third, this is an x, and this is just a constant. Well, if it's written in standard form, then the biggest exponent will be the first term, and the exponent on the x is 3, so this is a 3rd degree polynomial. So we'll look at B. Look through all the variables. The biggest variable in there is y to the fourth. So I start with negative y to the fourth. Next biggest is 126y to the second, followed by minus 53y, followed by plus 7. It's written in order from greatest to least. So the first term is the greatest exponent. It's a 4. This is a fourth degree polynomial. And then the last one, by now you should be seeing the pattern. M to the fifth is the highest exponent, followed by m to the third, followed by m squared, followed by m, and then 1. The highest exponent is m to the fifth, so this is a fifth degree polynomial. Okay, now we spent a little time before spring break looking at adding and subtracting monomials, or adding and subtracting like terms, so this part should be familiar to you. But here are just a couple of simple examples. If I have negative 6x to the fourth and 11x to the fourth, both terms contain an x to the fourth, therefore they're like terms. So when I add them together, all I do is add the numbers. Negative 6 plus 11 is 5. X to the fourth. Same is true when I'm subtracting. 2x squared y to the fourth minus 7x squared y to the fourth. Both terms contain an x to the second and a y to the fourth, so I just subtract 2 minus 7 and get negative 5 x squared y to the fourth. And notice in both examples I do nothing to the letters or variables and nothing to their exponents. I'm just adding their coefficients, or the number parts. Now these are pretty simple examples. You're going to get into some more complicated examples, and I wanted to show you two different methods that you can use in order to add and subtract polynomials. One's called the horizontal method, one's called the vertical method. I am more inclined to use the horizontal method just because I just have to write it out and do it. But I'm going to show you the vertical method just in case you might find it easier. So, if I just take this problem and rewrite it, all I have to do is distribute the negative. See, what you have is a polynomial minus another polynomial. And when you're subtracting this whole polynomial, you're going to subtract each term by distributing the negative sign. So what I end up with is x to the third minus 3x squared plus 5x. That doesn't change. And then I'm going to subtract minus 7x to the third and minus 5x squared and minus a negative 12. Well, minusing a negative 12 is really adding 12. Minus a negative makes positive. Then I just go through and, like I did before, find the like terms by circling those terms that have the same variable with the same exponent. I'm going to box all the x squared terms, triangle all the x terms, underline the constants. So x to the third minus 7x to the third is negative 6x to the third. Then I look at the boxes. Negative 3x squared minus 5x squared is negative 8x squared. Plus, there's only one x term, plus 5x, and there's only one constant. And that's it. That's my answer. So when you use the horizontal method, really nothing changes. All you're doing is distributing the negative. Now when you use the vertical method, you're going to write the first part down, like I've just done, x to the third minus 3x squared plus 5x. And then what you do is you take the second part and you write it underneath it. And you subtract it just like you would when you learned how to subtract 2- and 3-digit numbers. So, if you write it vertically like this and you're subtracting, really what you're going to do is subtract negative 12 and subtract 5x squared and subtract 7x to the third. So if I subtract negative 12, really what I'm doing is adding 12. 5x plus 12, well these aren't like terms, so all I can do is write 5x plus 12. So I'm going to work my way down each column. Negative 3x squared and negative 5x squared is negative 8x squared. And x to the third minus 7x to the third is negative 6x to the third. You get the same answer. It's the same process, just a different approach. Okay. Now, my suggestion at this point is to go back through your notes, put question marks where you get a little confused, and come to class ready to ask questions. Your assignment is this if you choose to get started early, and we'll see you tomorrow.